Welcome to Stoichiometry, another way, example number 3 with Dr. Poe. Okay, so here we have a different formula. We've got C3H8 plus 5O2 yields 4 moles of H2O and 3 moles of CO2. And the question is, how many moles of carbon dioxide will be produced from 50.0 grams of oxygen? Okay, so we know that we need to write out the given, because this is a stoichiometry problem. We're comparing two different chemicals. We're comparing carbon dioxide and oxygen, and we have an amount or a mole of each. So we want to know how many moles, and we were given 50 grams of oxygen, and we're looking at carbon dioxide. So carbon dioxide is here, oxygen is here, and our given here is 50.0 grams of O2 is oxygen, and our mole-mole ratio directly from the balanced chemical equation, and you can write this in either way. You could start with the, I just write it left to right, but you can write it CO2 first if you want. Oops, I left out the word mole. So we know that there are 5 moles of O2 in this recipe and 3 moles of CO2 in this recipe. Okay, and with that information, and we know that we want how many moles of carbon dioxide, we can set up our ladder. And so in these, we know the most number of steps is 3, so the given's going to go in a first, and we want, always write that over here just so I remember, the number of moles of carbon dioxide, 2 oxygens, 1 carbon. Carbon dioxide, good covalent compound there. Polar covalent even. Okay, so if you'd like to challenge yourself, go ahead and pause and see where you put your given, where you use your mole-mole ratio, because we know that we're writing it this way because we have to use those two things, and we use the molecular weights as needed to set up the problem or finish the problem. So those are our bookends only if they're needed. I'll just remind us of our goals. If I could actually spell goal, that'd be great. Goal number 1, we want the number of moles of the given. And goal number 2, we want to get the number of moles of the given so that we can use mole-mole ratio. I almost wrote ration. It's been one of those days. You probably hear my kid thumping around in the background of these movies. But that's okay. Okay, so to solve this problem, start with your given, 50.0 grams of O2. And our goal number 1 is we want the number of moles of the given. So we're going to have to use the molecular weight of O2 to solve this. So O2 is 2 times 15.99, or 16 depending on the periodic table you're using, and our molecular weight is always per 1 mole. If it's coming from the periodic table, it's always per 1 mole. That never changes. Isn't it nice when some things never change? Okay, and so this gets rid of grams, so now we have moles. Why did we want moles? It's for goal number 2, so we can use our mole-mole ratio. So now we can put our 5 moles of O2 on the bottom and 3 moles of CO2 at the top. So those just cancel straight out. And we want the number of moles of CO2. Well, by golly, isn't that what we have right now? Number of moles of CO2. So we are done with this calculation. So 50 times 3 divided by 32 divided by 5. I'm just going to double check my math. Okay, so I got my answer as 0.9375 moles of CO2, so just under 1 mole. So in this example, we only needed the molecular weight of the given. And the reason we needed that was to convert the units of the given from grams to moles. And we need the given in moles so that we can use the mole-mole ratio. What we wanted was the number of moles, so we didn't have to do any further conversions after that. But if we wanted the grams, if the problems explicitly asked for grams, then we would use the molecular weight. So let's use the same equation, but a different example. How many moles of carbon dioxide will be produced if 3.5 moles of propane, which is that C3H8, are used. Okay? And just to write out the equation again, because it's really nice to have. Nobody memorizes these things. It's 4H2O plus 3CO2. Okay, so go ahead, challenge yourself. See if you can identify the given, the mole-mole ratio, and set up your ladder. Because once you can do that, you are all set. So go ahead and pause the video if you need to. So given mole-mole ratio, and we're going to set up our ladder. And we will never need more than 3 steps to complete. And what we want is how many moles of CO2. So that's going to have to be the only unit on the top when we're all done. Okay, so in this situation, our given is 3.5 moles of C3H8. So our given is 3.5 moles of C3H8, and our mole-mole ratio here, so we're comparing C3H8 with CO2. So we're looking at this one, and remembering if there's not a number there, it's 1, and CO2 is over here. So we know our mole-mole ratio is 1 mole C3H8 equals 3 moles of CO2. So our C3H8 is going to have to be on the bottom. C3H8, so that the moles of C3H8 cancels with the moles of C3H8. And then the 3 moles of CO2 is on the top. And so this isn't so bad, right? Because actually we're done. Because we want moles and we've got moles. So they match. So 3.5 times 3 divided by 1 is actually 10.5 moles of CO2. Yep. Okay. And so as you can see here, we didn't use any molecular weights. Really, the only thing we used was the given here and the mole-mole ratio here. So the reason that you would use a molecular weight is either to convert the given to moles, if needed for the problem, or to convert the answer to grams, if needed for the problem. And all molecular weights are always per 1 mole. So I hope that this has been helpful to you.